Welcome to Mike's FJR Corner. Today I'm working on the front suspension. Originally when I was going to shoot this video, I was going to do an oil change on the front forks. However, I found out that the front fork seals were bad. So I proceeded to order new seals and bushings. And I proceeded to shoot the video for installation of the front bushings. However, that's when things kind of went bad. During the shooting of the video, I was assembling the front cartridge into the front fork, and I thought I had everything seated and bottomed, and I went to put the lower bolt in, and when I went to torque this down, which is 310 inch-pounds, which I think is too high, but more on that later. As I was torquing down, I heard something snap. And I opened it back up, and what snapped was the valve. This fits, there's actually a cup that fits into this, let's see, this way. This cup fits over the valve, like so. Of course, this piece is on the end, like this. Let me see if I can hold this all together. Okay. So the valve sits like this, and you have the lower part of the fork going up this way. You have the bolt coming in from the bottom, and it screws into here. So what happened, if this wasn't fully seated, it started to stretch this piece. I'm going to revise how I'm putting it together to ensure that this is fully seated before I install. But this presented a new problem. This valve only comes with the completed cartridge as an assembly. The assembly, depending where you look, is not available. I did find it on Partzilla. They did have the assembly. However, I started thinking, and maybe this is me just overthinking, but my thought is this has seals on it, okay, and it's got 90,000 miles of wear on it. And if I replace just one cartridge, I'll have one cartridge with 90,000 miles on it and another cartridge that's brand new. My thinking here is that you have one side that has no wear, and you'll have the other side which has 90,000 miles of wear. You may have unequal pressure between the left and right side. So I started doing some more research. I was looking into companies that may provide performance kits for the FJR and checking to see if they may be available. And what I found was the company K-Tech Suspension had a FJR kit for the Gen 1 series. This kit wasn't available on the US site, but I did contact them, and they said that they can order it through the UK and it would be here in a few weeks. So I was able to get the kit. This kit consists of, here, it consists of both valves for the left and right side, and also the piston for the left and right side. So this is complete valve performance upgrade for the FJR. So at the end of this video, after I complete the installation of the seals and bushings, I'll add a section for the installation of the K-Tech performance suspension kit. So let's get started. All right, we're going to start working on our front forks. We need to get the weight of the bike off the forks because it's supported by the stand. What I've done is I got some 4x4 blocks underneath. I got two running front to back, and then two underneath, which gives me about the correct height needed to support it by the headers. When this sets down on it, it's almost flat, completely flat across the wood. So we're going to take the lift, and I'm going to slowly set it down on the wood. The next thing I'm going to check is, now that the weight is off of the front forks, I want to check the triple tree to make sure there's no click. If there is a click, then we need to service the triple tree. I serviced it about 20,000 miles ago, so it should be good, but let me check to see if there's no click. Nope, it's good. Doesn't bind, no click, so we're good to go. Place a towel over the fairing to protect it. The first step is I want to loosen the top bolt. The bottom bolt in the triple tree I want to keep tight for now to hold the tube. That way we can loosen the top cap without this turning. With a 9mm hex wrench, let's loosen the triple tree. And do the same for the other side. We're going to loosen the cap on the top of the fork. Using a 24mm deep well socket, depending on the height of your socket, you may have to loosen the clutch assembly. I got it to just fit. I also have a piece of tape to keep from marring the bar, just to act as a protector. And I am using a swivel extension. So loosen the cap bolt. We're now going to remove the fender by removing this bolt with a 4mm hex wrench. Do this on both sides. We're now going to remove the back bolt with this 10mm socket while holding the nut on the inside. Do this on both sides. Now carefully remove the fender. Now we'll loosen the lower pinch bolts with the 6mm hex wrench. Depending on how much room your wrench takes up, you may need to remove the inside black plastic. The wrench I have fits just between the fork and the plastic. Take the wrench and loosen both pinch bolts. Now we're going to remove the fork from the triple tray. Slowly pull down, sliding it out from the triple tray. We're first going to disassemble the fork. We first need to drain the oil out of the fork, so I'm going to remove the cap. Okay, get the cap removed, pull the sleeve down, and pour the oil out. I'm going to hook it on the corner and just let it drain. I'm now going to put the fork in the device, clamping it from the caliper bracket. We're now going to remove the cap from the shaft. With a 14mm open end and a 17mm open end, loosen the nut. Then unthread the cap. Take a rag, hold it underneath, and pull the rod out. With an 8mm hex wrench, we're going to remove the bolt inside the fork. Slide it in and remove the bolt. I'm now going to remove the assembly from the fork tube. I placed the oil container underneath to drain any oil, and I'm going to slide it out and let it drain. Remove the fork from the vise and you continue to drain. Let the fork drain any remaining oil. Give it about 10 minutes. We're now going to remove the dust seal. We do that by taking a small screwdriver and slowly prying up underneath the edge, working our way around. Should come up pretty easy. And there we go. Slide it off. Now we have to take this little spring clip off from the inside. Take a small screwdriver, get under the edge of the spring clip and slide it out. There's the clip. Now we're going to remove the inner seal by slowly pumping the shock back and forth, hitting the end to drive the seal off. So I'll set the tube aside and let's drain the inner part out. There's a little cup that comes out that fits on the bottom of the assembly and slides into the fork. Clean the cup. This is what you have on the inner tube. We have an oil seal, a washer, the upper bushing, and the lower bushing. We're going to be replacing all of these components. So let's remove the seal, set it to the side, remove the washer, and remove the bushing. We're going to remove the bushing by taking a small screwdriver into the slot, pry up slightly, then push the bushing over the end. Do that with both sides. The bushing should slide right off. Clean the tube in your favorite degreaser. Make sure your work area is clean and free of dirt. Now that the tube is completely clean, let's set it aside, put it in a safe place so it does not get scratched. Clean the top in your favorite degreaser. I removed the knob off the top so I can get all around this edge clean. And I'm also making sure I got all the dirt out from inside the grooves. Let's get it nice and clean. Clean the cup. Clean the spacer and the clip. Now we want to clean the lower part of the fork. I'm going to take our degreaser and spray it down and use a brush to get all the dirt off. Once we have the bottom of the shock completely clean, set it aside. I'm now ready to assemble the left shock. I have all the parts clean. I have all the new parts laid out with their part numbers, and I have a reference diagram for the assembly, and I'm ready to get started. The first step is I'm going to apply grease to the bottom housing. I'm going to take a little bit of grease and apply it to the inside edge all the way around. This helps allow the seals to go in. So just a light coating all the way around. Now I'm going to install the bushing onto the tube. It's part number 4SV23135-10. I'm going to take the bushing and I'm going to slide it onto the end of the tube, and it should just slide right on. The first step of the assembly process, I'm going to take a little bit of the fork oil and put it on the bushing. Put a thin coat all the way around. Now let's put the lower shock assembly into the vise. Apply a thin layer of grease to the inside of the bottom of the inner tube. Insert the cup into the bottom of the inner tube. The grease will act like a glue to hold the cap in position. The little bit of grease that we use will dissolve when we fill the fork with oil. Slide the inner tube into the bottom assembly. Make sure the cup does not come out and both the cup and the tube is fully seated on the bottom. Now put a thin coat of fork oil on the inside of the upper bushing. We'll also put a thin coat of grease on the outside of the top bushing. This will allow the bushing to push into position easier. Slide the bushing, then the washer onto the inner tube. Using a 48mm fork seal installation tool, drive the bushing into the lower fork assembly. Once the bushing is almost in, use a mallet to finish driving the bushing until the bushing is fully bottomed. As an alternative to the fork seal installation tool, you can get a PVC 2-inch to 3-inch reducer coupler. Use a hole saw to remove the plastic ridge inside the coupler. The inside dimensions of the 2-inch opening measures about 48mm. This fits perfectly onto the tube and sits flat on the bushing. The only downside is you don't have any weight, so you may have to use a larger mallet to drive the bushing in. Also, you have to make sure the bushing drives in straight. Put a thin coat of fork oil on the inside of the seal. Put a thin coat of grease on the outside of the seal. With the number side of the fork seal facing up, carefully slide the fork seal onto the tube. Using the 48mm fork seal tool and a mallet, slowly press the fork seal in until it bottoms. Wipe off any remaining grease. If everything is seated correctly, the fork seal should be at the bottom of the snap ring groove. Slide the snap ring onto the tube. Using a small screwdriver, carefully slide the ring into the groove. Apply a thin layer of fork oil to the inside of the dust seal. With the tapered side of the dust seal facing up, Slide the dust seal over the inner tube, pressing it down into the fork assembly until it's fully bottomed. With the groove lined up with the keyway on the fork guard, slide the guard over the inner tube down onto the fork assembly. Using a mallet, carefully press the guard onto the fork until it is fully bottomed. Put the fork horizontally into the vise. Put the cartridge all the way into the bottom of the inner tube, placing the shaft of the valve into the opening of the bottom of the fork. You should feel the valve slide into the bottom. Place a new crush washer onto the fork bolt. While holding the cartridge in place, use a 6mm hex wrench and slide the bolt with the crush washer into the bottom of the fork. Turn in the bolt clockwise about 1/2 turn. This is so we can check the depth of the bolt and determine if the cartridge is fully seated. I found out the hard way that if the cartridge is not fully seated and we try to tighten down the bolt, we can snap the valve. While holding the cartridge into the inner tube, use a depth gauge. Measure from the center of the bolt to the edge of the fork. The measurement should be approximately 44mm. If the depth is greater than 44mm, make sure the cartridge is fully seated in the fork. Once we determine that the cartridge is fully seated, with a 6mm hex wrench, lightly tighten the bolt. The specifications for torque is 310 inch-pounds. However, I'm tightening mine to 220 inch-pounds. I feel given I broke the valve, the specifications seem too tight for the situation. 220 inch-pounds should be fine. Now place the shock again vertically in the vise. With the inner tube fully compressed, add approximately 24 ounces of 10W fork oil. Slowly pump the damper rod up and down, at least 10 times to distribute the fork oil. Slowly pump the inner tube up and down, at least 10 times to distribute the fork oil. Wait at least 10 minutes for the oil to settle and any air bubbles to disperse. While we're waiting for the oil to settle, let's set up our measuring gauge. This fork level gauge I made from a brake bleeder, metal tube, sink pop-up stopper clamp, and an electrical box light mount. Alternatively, you can also buy a variety of fork oil level gauges on Amazon. Adjust the gauge for the stock fork to 79mm. With the inner tube fully compressed, place the gauge flat on the top of the tube. Pump the vacuum pump until it sucks air. With the closer spaced coils on top, slide the spring into the inner tube. Place the washer and spacer and then the nut onto the damper rod. Turn the nut until it is hand tight against the spacer. Now insert the adjusting rod into the damper rod. Adjust the preload and the rebound adjustment all the way out counterclockwise. Place a new O-ring into the adjuster cap. Apply a thin layer of grease to the O-ring on the adjuster cap. Screw the adjuster cap all the way onto the damper rod until it is fully bottomed and finger tight. With a 17mm wrench holding the preload adjuster and a 14mm wrench on the nut, tighten the nut. Slide the inner tube up onto the adjuster cap. With a counterclockwise motion, screw the tube onto the adjuster cap. With a 24mm wrench, lightly tighten down the cap. We will torque the cap later when we mount the fork onto the bike. Adjust the preload adjustment to the standard third line, counting from the top line down to the third line. Adjust the rebound knob to the in direction clockwise till it stops. Turn counterclockwise to the standard setting of 12 clicks out from tight. Adjust the compression adjuster to the in direction clockwise till it stops. Turn counterclockwise to the standard setting of 12 clicks out from tight. The left fork is now complete. Repeat the disassembly and assembly procedure for the right front fork. To fix the broken compression valve, here is the upgrade of the fork cartridges with the K-Tech Performance Valve Upgrade Kit. With the cartridge held in the vise with the soft jaws, loosen the compression valve using a 26mm wrench and a 19mm wrench. Remove the compression valve. Inside the cartridge there is the rebound valve. Slide the damper rod out of the cartridge, exposing the rebound valve. Before we remove the valve from the damper rod, we need to measure the adjuster rod. Mount the damper rod into the vise with the soft jaws. Using a depth gauge, put the tip of the gauge on the damper rod and the gauge on the adjuster rod. Push in till the valve is fully closed. Now release. The gauge should measure about 22mm. Write the exact number down. We will need this number later. With a 14mm wrench holding the nut and a wrench on the rebound valve, loosen the valve. There are some differences in the way the new valve works. The old valve has the needle contained within the valve. The new valve, the needle sits inside the damper rod. The problem with this arrangement is the needle is 5.7 millimeter, but the inside diameter of the damper rod is 5 millimeter. So we need to widen this hole to 5.8 millimeters. To do this, I'm going to use a drill press and 3 different sized new drill bits. I'll start with 1364 bit, then next I'll use a 732 bit, then I'll finish using a number 1 bit, which is 5.8 millimeter in size. Use a piece of tape to mark about 1 1/4 of an inch from the tip of the drill. We need to hold the rod on the vise as close to as straight as possible. I happen to have inherited a compound cross slide vise with a rod holder. You may use other methods to hold the rod as long as it is aligned straight and it cannot move. First, we're going to drill with the 1364 drill bit. Place this bit into the drill and align the drill bit with the tube. Apply a small amount of cutting oil. Slowly lower the drill and just touch the top of the rod. Check to see that the drill is centered. Slowly lower the drill, occasionally lifting the drill to remove the cut debris. Continue to drill the rod down to the edge of the tape. Once finished, remove the drill and insert the 7/32 bit into the drill. Again, apply a small amount of cutting oil. Slowly lower the drill, occasionally lifting the drill to remove the cut debris. Continue to drill the rod down to the edge of the tape. Now remove the drill and insert the number 1 bit into the drill. Now apply a little more cutting oil. Slowly drill the rod down to the tape. Take care that you go evenly. This is the final cut. The damper rod is now finished with its inside diameter at 5.8 millimeter with a depth of 1 1/4 inches. Let's put the rod back into the soft jaws in the vise. Put a coat of fork oil on the end of the new needle and damper rod. Insert the flat end of the needle into the damper rod. Then insert the spring. Screw the new rebound valve into the damper rod. Using an open-end wrench, tighten the valve until it bottoms. Using 2 open-end wrenches, tighten the nut against the valve. Insert the adjuster rod and take a new measurement. Using a depth gauge, put the tip of the gauge on the damper rod and the gauge on the adjuster rod. Push in until the valve is fully closed. Now release. The gauge should measure about 42 millimeter. Write this exact number down. Now if we subtract the previous measurement from the new measurement, we get about 20 millimeter. This is the same measurement that K-Tech says we have to cut off the adjuster rod. Make a mark on the rod 1 millimeter shorter than the measurement, 19 millimeters. We will take the extra 1 millimeter off with a file later. Place a piece of tape along the mark. Put the rod into the vise with the line just inside the edge of the jaws so we can cut against the vise without cutting too far in. Verify that we are only cutting off 18 to 19 millimeter of the rod. With the saw, cut the rod. File the end of the rod to take off any burrs. Clean the adjuster rod and insert it into the damper rod. Now let's take another measurement. You should measure about 23 millimeter. Continue filing until the measurement equals your original measurement of about 22 millimeter. Clean both rods and insert the damping rod into the cartridge. Lubricate the rebound valve with fork oil, then slide the valve into the cartridge. Lubricate the compression valve. Carefully slide the valve into the cartridge, then screw it in clockwise till it bottoms. Using a 26 millimeter wrench and a 19 millimeter wrench on the compression valve, tighten the compression valve. The left fork cartridge is now complete. Repeat this process for the right fork cartridge. With the K-Tech kit, there's a new fork oil level of 105 millimeter. We need to fill to this new level when assembling using the kit. There's a new setting for the rebound of 20 to 24 clicks out. I set mine to the middle, 22 clicks out. Also, there's a new setting for the compression as well, 8 to 10 clicks out. I have mine set to the middle, 9 clicks out. Now we're ready to install the forks back into the bike. Slide the left fork into the triple tree. With a 9 millimeter Allen wrench, adjust the edge of the inner tube just above the clamp, about 2 millimeter. Lightly tighten the upper clamp to hold the fork from moving. With a 6mm Allen wrench, tighten the lower clamp bolts. There are 2 bolts in the lower clamp. They need to be tightened evenly. The specifications for the lower clamp is 200 inch-pounds. I'm going to tighten each pinch bolt by alternating between them. Slowly tighten each bolt. Then torque the bolts to 170 inch-pounds. Then once they're both torqued, do a final torque of 200 inch-pounds on each bolt. Tighten to 200 inch-pounds. With a rag over the bar to protect it, use a 24mm socket and torque to 220 inch-pounds. Now we're going to torque the upper pinch bolt to 300 inch-pounds. Repeat the procedure for the right fork. Insert the bolts for the brake hose clamps. Tighten the bolts to secure the clamps. Place the fender between the forks. Insert the rear bolts, then put the nuts on the bolts inside the fender. Insert the front 2 bolts. Tighten all 4 fender bolts. Here's a compression of the front forks. There seems to be less dive, and the rebound also has almost no bounce. My impressions on the road are, it feels better planted. I don't notice much dive or weight shifting during braking. I definitely can feel that the front end does not seem to compress down as much in corners. As far as the ride, I had mine previously set tighter than stock, so the ride seems comparable. The settings provided by K-Tech seem spot on. Almost no difference in the ride from my old settings, plus a big improvement in handling. I'm happy with the upgrade, and in some ways, I'm glad I broke the valve. Well, I hope you enjoyed the rebuilding of the front forks. If you like this video, click on the thumbs up or hit the subscribe button. I thank you for watching, and goodbye.